Hi everyone, welcome back to our building blocks of EHS systems. Today we are going to go through BB4, the hierarchy of hazard control measures, and sometimes it's called hierarchy of risk control measures. I hope you will not forget to subscribe to our channel, BB4 Safety, so you will enable us to continue giving service. Okay, two things you should note. Please keep beside you a pen and paper to write down notes and questions you may want to ask, and always watch the social distancing until the COVID-19 precautionary measures are no longer required. Okay, why it is important to study the hierarchy of the hazard control measures? There are 4 points for that. The efficiency of our solution or the control selected, the priority of it, which one should be first, the cost comparison between different solutions, and whether it's suitable for this situation or not. One good example for this is if we have people working or somehow near HOS areas, but due to the culture, they are growing a big beard. So the solution of just a mask maybe is not suitable, and then we will go to maybe a breathing set with hood instead. So suitability of the solution is very okay. In BB4 we will cover few points. What we mean by hierarchy, is it a descending or ascending, or can we read it both ways? And example about each control method, and how we can use the combinations, and there will be some exercises and quiz of a real, some of them are real problems, and you should consider yourself the guy from management or from safety that is trying to find a solution for that. And then the PPE, last but must. There is some very important thing about PPE we need to discuss here. Okay, let's start. As usual, we start by reminders of things that we need to know in order to make sure we are familiar with the terminology that will be used during the module. The three reminders today are hazard and risk and pair. So hazard, as we know before from the previous lessons, is anything with the potential to cause harm, and to what? To pair. And what is pair? People, environment, asset, and reputation. And as we said before, these are arranged in the rank of their importance, people being the most important, then environment, then the assets, and then the reputation. They have, all of them have a big impact on us, but when we see what is a priority of saving will be the people and then the environment and so on. Okay, and the pair, as we see here from the pictures, people, the environment, and of course damage to environment including pollution of air, water, and soil, and to buildings and equipment, assets, and of course reputation. You can see here this group of people demonstrating against a company that they believe have done something wrong. And in the first one, the people, you can see the trains that came off the track. Okay, so this should be clear in our mind. What is the hazard? What is fair? And now also, we should also make sure to know what's the risk. And we said before, risk is a combination of severity and probability. And it is a simple formula: R, risk, equals severity times probability. In the picture, of course, there is a big difference from those that do risk management and risk assessment and make sure that all the hazards are controlled, versus those who are careless, which looks like gambling. Interesting thing is the word hazard came from the Arabic name for the dice, az-zahru. So when we take risk or accept a hazard, we are gambling with our life. Okay. And this formula will be used later in one of the other modules to calculate risk. And based on that, we will decide something about the control measures. Okay. But as we said, this hazard control measures is part of a bigger process, which is the risk management. So we have a hazard we have identified, and then we need to manage that one. So what is this process of risk management? So first we identify the hazard. We said this is the most significant, and then decide who might be affected and how we will be affected. And then we do the risk assessment from a matrix that you will learn in a future module. And then we decide here on the implementation of the control measures. Why this came after the risk assessment? Because sometimes the risk is acceptable. It's very low risk. Maybe sometimes we don't need to do something about it. So once we arrive to the implementation, we have already decided this control measure according to a certain ranking or hierarchy. And that is the subject of our module today. What is the ranking, the hierarchy of the control measures we are taking? So I cannot every time start with PPE. Any hazard I face, okay, I'll get earplug, I'll get glasses. So we need to implement the control measure in their proper hierarchy. Okay, we need to consider them in their proper hierarchy. And then, of course, we will record the finding, we will implement, and then we have a feedback and see whether our solution was successful, what are the difficulties, is there any new hazard that appear because of the use of the first control, and then we would review all that. And by reviewing these records and the feedback and any incidents that may happen, we will see if we try to identify the hazards again in case new hazards arise, and so on. So this is a cycle, and we are now interested in the one related to implementation of hazard control measure in proper hierarchy. Okay, please review this slide again or stop the video and try to understand it. And that will always keep this subject in its perspective. Means you know its importance, and it is preceded with something and followed by something. Okay, what we mean by hierarchy? Hierarchy means things are ranked or arranged one above the other. There is some of them come first and some of them will come later always, right? And the hierarchy of hazard control measure is a step-by-step method to minimize and reduce the effect or the exposure to the hazards, right? What are these sequenced steps? As it is mentioned here, this slide, we will explain later one by one. But the first one is elimination. The second one is substitution. The third one is isolation. This is recognized independent by ADNOC and maybe NEBUSH. Some other systems that isolation is part of other things like design and administrative. But here in isolation, number 3, number 4 is engineering and design, number 5 administrative control, and number 6 personal protective equipment. Okay, so what kind of ranking or order we have for these control measures, and what kind of significance we should understand about this ranking? As you will see in the next slide, 2 slides, there is the efficiency, and it is arranged always in a descending order, means the top hazard control is the most efficient that we should always consider, and then the second one would be the second in efficiency, and the last one is the PPE, the least in efficiency, and we will discuss why it is the last. Okay, the second thing is the ease of use, how easy it is, what kind of users we are expecting to use them. Are they illiterate people, just laborers? Is it easy for us to maintain it? And then the preference of use and the cost. The preference of use or suitability, I mentioned that in an earlier slide. Okay, we can see now this upside down triangle, and it has 6 control measures. The elimination is our first solution. We try to eliminate or remove the hazard completely, and there is an explanation. The second one, substitution, we replace the equipment or the material we are using with something that is less hazardous than the first one. Then isolation, separation between the hazard and those that can be affected or restricting access by barriers. Then engineering control, we are using design and engineering method to control a certain hazard. Example, the ventilation in confined space. Confined space have a poor ventilation by nature, and we need to maintain a certain percentage of oxygen, and we should make sure there is no accumulation of other gases, and that's why we use ventilation. This ventilation has to be with a certain capacity per hour or per minute or amount of cubic meter of air changing in the room. That will be engineered and calculated, not just put a fan, for example. Then we have administrative controls, which is a very big list. Start by training, rules and regulations, the permit to work, the safety data sheet or material safety data sheet, labels, signs, fines, penalties, audits, inspections, a lot of things will come under the administrative. And administrative also is very important because it comes with almost all the other ones. It comes with always all the other ones. So it is used in addition to them. For example, if you have a machine designed to do a certain job, there must be some instruction how to use it and what you should not do and all that. And with PPE, that areas will be marked with signs showing a necessity to use a certain PPE in that area. There will be signs showing where it is kept. There will be posters of how to use it or don it. There will be also maintenance procedure and cleaning procedure and inspection program. All these will come under administrative. And then we come to the PPE. PPE, the standard PPE are helmets. We are going to talk about that in the next slide. But anyway, standard PPE that we should have always when we are in work site. At least we should have a helmet, safety glasses, earplugs, dust mask, pair of gloves, and coverall and safety boot. Then there are specific ones we'll talk about in the some of the next slides to come. Okay, here the explanation I just mentioned, and you can see that the arrow on the right side, which is taking the same colors of the hierarchy of controls, and the safest one will be the elimination or removal of the hazard completely. And we put red with the PPE. We know that PPE is a must, but the hazard is still there. We did not remove the hazard. So that's why I use this red color, just to remind you that with the PPE we have accepted the hazard rather than trying to do something about it. Okay, let's see elimination. One of the good example of elimination is halon. Halon, as you can see in the picture, was used as, in fact, it was the best firefighting agent, clean agent ever invented. This group of gases, the chlorofluorocarbon, was found to cause damage to the ozone layer. And the ozone layer is very high in the atmosphere, several kilometers, and it is responsible for protecting us from the UV rays from the sun, and which may cause skin cancer, for example. So the scientists noticed there is a hole in the ozone layer, the ozone layer being depleted by these type of gases. So several measures was tried, but none of them work. Eventually, all countries signed an agreement, and halon was phased, was banned and removed. Of course, we cannot dispose it, because if we dispose it, we will damage the ozone layer. So it was banned. All new manufacture was banned, and the existing one, they made halon banks all over the world to collect it, and it was only allowed for the space and the military and the aeroplane industry, like protecting hangars and all this. So it is a good, because you cannot just keep it and waste the money, so it is used for these sensitive industries. So halon was one of the examples. Another example is smoking. it was found that passive smoking affects the non-smokers. So passive smoking is somebody is smoking in the room. We are there all the time. We are his colleagues or her colleagues, and we are not smoking. But it was found that passive smoking affects the non-smokers very, very badly. So smoking was banned. Smoking was banned from public places and from aeroplanes. Believe it or not, aeroplanes, people could smoke inside the aeroplane before. Okay, the second control measures we have, second control measure is substitution, which is simply replacing uh, the equipment or material that is causing the hazard with something less hazardous. Example, you remember the halon we mentioned in the previous slide, last slide, about elimination. Okay, now they have invented a replacement, other clean agent to replace the halon as a firefighting clean agents. Another example, use of 110 volts instead of 250 volt. As we know, the current passing in our body is the one that damage our tissue and cause all the problems. So obviously, if I have a higher voltage, the current passing in my body, if I get an electric, will be higher. So using a lower voltage is reducing the risk. The other one also is, another example is use of battery operated power tools instead of electrically operated power tools. The exercise here, you can see the picture. There is some warning from dairy products, or there is label on the certain products say there is no dairy product. Obviously, some people are allergic and it affects their body. So we have to substitute with something else. Also sugar. There is some sweeteners there. So you need to find out something in your day-to-day life that you think an item was substituted by something else to reduce the hazard. The third is isolation. And isolation simply is a physical separation of those who are affected and the things that can be affected from the hazard itself, including barriers. Right? When crane is being operated and we put barriers around that area to limit the access, so we are sure nobody is moving under suspended load. Areas with radiography also, we surround them and put flashing light. But the barrier or fence that we'll put around is a form or one of the forms of isolation. Also, segregation of chemicals. We segregate flammable chemicals from oxidizers. Simply, there is some chemicals are not compatible. They are not compatible with other chemicals. If they mix, they can cause reaction and cause a problem. We have a very famous accident. Okay, maybe not very famous, but it's a big accident where a warehouse that was used for storing hazardous chemicals, both the storekeeper and unfortunately the safety officer didn't know how to read the labels. So they stored flammable material with oxidizers because both of them is showing a flame. They didn't know they are incompatible. So on the this exercise here, I want you to find out what is the label, because you are going to send to me. You're going to send to me your answers, right? There is an email at the end. So you find out what is the label for flammable and what's the label for oxidizer, and you can see that if you don't know, you will think they are both for flammable, so they store them together. So when the fire happened, they couldn't put it off. Okay, so segregation, use barriers. So also energy isolation using lockout and tag out, right? We can also look to lockout and tag out as a design and administrative. So the lock being a design and the tag being administrative, so the LOTO. But anyway, the system of LOTO will isolate energy. So there is different ways of looking at it. When we do the PTW, we will take every hazard that ADCO or ADNOC wanted us to study, and we will apply these principles and we'll try to identify what kind of control was used. Okay, now we come to engineering and design, which is everywhere around us. Acoustic enclosure of generator. Generators are noisy by nature. So they design a cover, an acoustic enclosure that will reduce the noise to an acceptable level. Okay, so also guards, you have a fan, electric fan in the house or in the workplace, and the guard that covers the blades is a design control, engineering control. Now we come to the point of suitability. This fan, I cannot use it, for example, in a kindergarten because the children fingers can pass through. So suitability of the solution, it depends on where I'm using it. Okay. Other designs will be relief valve, for example, or emergency shutdown valve in a process plant. These are designs, right? Ventilation and explosion-proof light in confined space. In the picture, it's very interesting. On the left side, there is different ways to ensure that the bottle is not being tampered with. And this is range from the way the cover is made. You have to break the seal, so it will be very obviously somebody used it. If it is a bottle for medicine, you may have to do two actions if the medicine is dangerous, as we asked earlier, or sorry, there is example later in the quizzes. And maybe some of the medicine bottles, the cover itself, you need two actions to push and turn, or even sometimes you turn opposite, okay, to make sure children cannot open. In the middle, this is, there is a shutter here, and you need to, the plug itself, the rod for the earthing is the one that opens the shutters. So if the child tried to put something very thin inside, it will not reach or make contact with a live wire. Of course, there is another system to back this up, is circuit breakers, right? So and then that one, that design around the valve to collect leaks and or emissions that may be until it is replaced. So that was engineering. There is so many examples that you can find and think of. Okay, we come to the very interesting and very important, the administrative. The administrative is rules and regulation and policies. So no smoking policies, facial hair policy, no alcohol, no gambling, no fighting, all these type of policies, no smoking, all these type of policies are administrative. Warning letters, bonus, fines because of overspeeding, all these are administrative. Medical checkup, inspection, auditing, color coding, fire watchman, signalman for the crane, you name it, a lot. Medical checkup, maybe I mentioned already. Okay, so this wind socks, what do you think? What kind of hazard control measure it is? Is it a design? Is it administrative? I would like to hear from you. I would like to hear from you. I didn't put numbers for the questions, but obviously I can check which one you didn't answer. So the last and the least effective, the last and least effective is PPE, personal protective equipment. As we said, we have standard ones we mentioned before, and it's mentioned here, and we have a specific like leather apron and long sleeve for welders, face shield against the chemical splashing. There are a lot of apron with lead for radiation, for radiography, so, and X-ray technicians. Okay, so these are the specific ones, but whether it's a standard or specific, why PPE are considered the mask we use for the mask we use for COVID-19 is a PPE, but why it is considered as the last, the least, and the last? Okay, let's see some of the reasons. Okay, the first thing is, as we said, when I use a PPE, I have accepted the hazard. I did not try to remove it or reduce it or do something about it. I accept the hazard will be there, and I have the PPE against that. Some other things is they are not fully understood. So not all gloves can be used for all chemicals. Some of them are very good for alkalis, some are used for acids, right? Electrically insulated gloves, which are very expensive. But if this glove have a pinhole, very small pinhole that we cannot see, it becomes useless. So PPE are have limitations. We need to understand the limitations. Breathing apparatus have a safety protection factor, which is very important, and this factor come in numbers, and with a certain concentration, let's say one of the toxic gases, hydrogen sulfide, above, for example, 1,000, need a certain protection factor. So not all breathing apparatus can work in any concentration. So there are limitations. There are many things that we don't know about PPE. You have a cartridge mask for a certain vapor or gas, and you are going to use it, but you don't know what's happened to that cartridge, if the material inside is spoiled, damaged by heat or humidity, right? Breathing apparatus is a very good example. Let's say we are in a workplace and we have decided, we took many precautions, but our last line of defense, and I will explain why it is our last line, is the PPE, and we have decided we need to use the PPE. So we provided them with PPE, the breathing apparatus, the SCABA, and provided with the training, supervision, sign showing where we keep it, drills, and to make the people use it in a proper way and in a certain very short time. We have done all this. Then, while you are working, suddenly the alarm sound indicating a release of hydrogen sulfide toxic gas, and you acted as you have been trained, right? So you did everything correct, and you went and you took the breathing apparatus from the box and you done it, and then it is empty or half empty. So they have limitation. This is empty because the previous users did not report, or maybe the cleaning people forget to close it, or some part moved and it's leak air. Anyway, at the time of emergency, you find it is only 5 minutes left, or maybe it's empty completely. It's too late, too late. So PPE are not reliable, not the best reliable. So now we come why it is a must. Because if I use the hierarchy for some of the hazards, let's take noise, and I try to eliminate the noise. Let's say this one is a certain equipment that I cannot use, I cannot eliminate. Let's say jackhammer, for example. I cannot eliminate the noise of a jackhammer. I cannot isolate the worker from the jackhammer, whether the noise or the vibration. So I cannot eliminate, I cannot substitute if I need to do a certain job with a certain efficiency and producing a certain amount. I have to use the jackhammer. Okay, so what is left for us if I cannot eliminate, I cannot substitute, I cannot isolate, and I cannot design a jackhammer that cannot vibrate or cause noise, of course. So I'm left now with the administrative and the PPE. So administrative will be the training, the science, the supervision, the medical checkup frequently to make sure that their hearing is not deteriorating or they don't have some sickness because of the vibration. But let's concentrate on noise now. So, and then we will give them eventually the PPE. The training for the PPE also, not all earplugs or earmuffs are suitable for any type of noise or any level. Whenever you have an earplug, and this I will show maybe when we have a module about PPE, whenever you have an earplug, you will see something called NRI and a certain number, NRI 23, NRI 18, and that is noise reducing index, sometimes NRF, noise reducing factor, and this is the factor that will be used to calculate how much noise you have at your ear. So if I am in a refueling helicopter, and we have measured the noise in refueling helicopter before, it was 120 decibel, and then the acceptable level in that company, let's say it's 85 decibel. Some companies are 80, but now we have 120, and that company accept maximum 85 decibels. That's for 8 hours for 5 days. And then I have an earplug or ear muffs, looks very nice, but the NRI is 30. So 120 decibel, I have to deduct 30, the noise reduction index or factor, and now I have 90 decibel, not acceptable. So we need to understand that, and that's not every earplug will fit, right? By the way, child is screaming sometimes reach 120. And don't ask me how I find that. Okay, so very important now. We have now find out that although PPE are very important, they have some limitations. And that's why they are the last choice when we try to manage a certain risk. They are at the bottom of the hierarchy of other control measures. Okay, what is the note in yellow? Now, I cannot go, even if it is true, I cannot go to laborers and workers and say, oh, good, you have your PPE, but by the way, they are the least effective. This message will not be properly understood and it will confuse them. So we must, for them, PPE is a must. And it is a must for us also. It is the last line of defense. They don't need to be confused by telling them it is the least effective. All they need to do, if they have to use the proper one, use it in a proper way, maintain it and clean it, and always show up to the work site with it. Okay, so that was the PPE, our sixth hazard control measure. Okay, we're going to have some questions, quiz, and some pictures. And I'm trying to explain now what I'm expecting you to do. I want you to read the scenario, look the picture, and try to understand what is going on. We are trying to identify the hazard, of course. We said in the BB3 that we cannot control the risk of the hazard if we don't identify it. So our first task is to identify the hazard in the picture or in the written question. I may put a certain different ways of question on the picture, but they're all, your solution will always start by you writing down what are the hazards. You are going to use the hazards categories. You are going to imagine you are there and you are using your senses. So, of course, we are using the visual or seeing, but if I consider listening, then I would automatically think, does this equipment have noise or cause noise? And then I will consider that. So I can still use my senses, even in an imaginary way. And the second thing is, we are going to think of where this hazard will be. Okay, and don't forget what we said in BB3, that hazard in any workplace will originate from three sources. The first one is the nature of the place itself. What kind of operation is this? It's a chemical plant. Is it a gas plant? Is it the drilling rig? It's an offshore production facility. Each one of these have its own hazards related to the nature of the operation. The second one is what activity is being done, what you are doing there. Are you a welder? Right? Are you a painter? Are you refueling a helicopter? You're exposed to fumes or So first one, second one is what is the activity being done. And the third one is the surrounding or the environment, the surrounding or the environment around you, including weather or sea condition, right? But the surrounding could be another job. We are here in this plant, and 1.5 kilometers away, a drilling rig flaring, and everything was fine until the wind changed its direction. The wind changed its direction, and then now we became downwind, and the air bringing all the toxic gases to me. Why I didn't notice that? Well, because maybe I didn't have wind socks. You remember the wind socks we talked about? Now you should think, what is the wind socks doing now? And that will give you a clue to answer the previous question. Okay, this is the first image. You should identify the hazards and see the clothes, the loose clothes that can be caught in the rotating blade. There is nothing to stop his hand from sliding. There is nothing to stop. There is a lot. There is no proper guard. You can see the belt. Okay, there is a guard for the blade and it's not complete, but there is no guard for the belt. So you have to find out. I'm just giving you, helping you the first one. Here, these guys looks, they are wearing their PPE, but there's one of them is on the top of that big pipe, right? Beside, can the signal man, which I assume is the guy next to the operator, can he see the other guy on the other side of the pipe? Think about it. Think about it. Also, the radius is extended too much. Is it within the proper limits, or the whole thing can topple? Also, one good thing you need, if you really want to improve, you take this picture, for example, for grinding, and you search for what is the code. We have a code actually for the blades of the grinder, and excavation, laying down pipes. All this you will find videos about how to do them in the YouTube, and you can come back and comment on this. Okay, these two guys, what is missing? Okay, this is a chemical lab, and what kind of hazards there? We have acids and alkalis, we have fumes, we have vapor, we have gases. On the left side, you can see that bench, and you can see the grill there. This is actually a ventilation hood suction for any fumes if they are mixing some chemicals. Try to find out what is missing from the controls. Go one by one. Okay, so a chemical lab should have chemicals, so maybe cannot always eliminate or substitute. We may substitute, but there will be chemicals in the chemical lab. Now we should think, what is next? Isolate, design, administrative, and PPE, right? For example, where is the labels and posters, warning posters, right? There's nothing, none of them on the walls here. Now we come to some interesting quiz, and this I need you to write and think about it. This is a family. The father is diabetic, he's taking diabetic medicine. Of course, if children took diabetic medicine, it can cause a fatality. So what can be done for this problem? And when we see what can be done, is not what the father only, no, the manufacturer of the medicine, the pharmacist, the father, and then the children. We should not expect too much from them, but it depends the age, what kind of age. Second one, it's a warehouse. Sometimes it's hot, or they are carrying boxes and they don't want the door to be open and close, open and close. So the easiest thing is they take the fire extinguisher from the wall, from the bracket, and they use it as a stopper. And there is no guarantee that if there is a fire, that this fire extinguisher will be in a good condition. So you must find out what could happen, what is the hazard, and what are the controls to make sure this effects or consequences will not happen. We come to this one. This is a walk-in freezer to store meat and fish. And this is a real accident that happened offshore. The cook, as you can see, he went inside that walk-in to get some fish. And then the wind slammed the door open. Slammed the door closed. So, as you can see from the picture, from the blue line, there is a mechanism to allow you to open the door from inside. It didn't work. There is also light inside. You can see the light in the yellow line. The light was not working. So he couldn't come out. It was complete dark. It's minus 18 degrees, sub-zero temperature, right? Unfortunately, that was working. So what happened to him? He was trapped. As a precautionary measure, there is a cold coat, a coat for cold, always there to be used. That was also missing. There is two of them. Both of them were gone. Also, there is an alarm. You can see the alarm, the red arrow. That alarm is outside, and it should be activated from inside. It didn't work. So now, didn't work. We must find the root cause. We are going to talk about that, but I want you to identify the hazard and what you are going to do about it. You are supposed to prevent reoccurrence. Okay, there is two more questions. The second question is the walk-in freezer considered a confined space? Before you answer, search and find what is the actual definition, accurate, correct definition of confined space, and let me know, because this is a very important one, whether it is a confined space or not. And the last question is, how are you going to classify this accident? In our module 2, we're going to release that is about incidents and accidents and how you are going to classify this accident. Think about it and let me know. Think about it. If you have any questions, you can always send to us in this email, 2020bboss@gmail.com. And of course, we thank you for watching this video. I hope it was interesting. There is a lot of information. It looks at the beginning as a small, straightforward subject, but there is a lot of ideas behind it. Please review this video as many times as you want, because it's very important that all the information are clear for you, that you don't need to refer to the video again. Of course, whenever you want, you can, but I mean, it should be like your second, like a back of your hand. You should know it by heart. Okay, again, don't please forget to subscribe to our BBOS safety channel on the YouTube. And you have here the telephone number and emails, 2 emails. 2020 BBOS, you can send for the answers or things related to the module. If you want something about the training, you can use the md@transtk.com. Okay, thank you very much. Okay, guys, before I leave you, I would like to thank our sister company, Transtech Solutions Limited, for sponsoring these courses and allowing us to make it free for you. Transtech Solutions Limited is the agent in the GCC countries of NovaCool. What's NovaCool? As you can see here, is a firefighting foam. But it's not just a firefighting foam. It is really a miraculous product. This product, as you can see, I put for you the website so you can see a lot of videos. This product can even extinguish not only Class A and Class B and Class C fires, can also extinguish Class D fires. And Class D fires, for those of you who don't know, are metal fires like magnesium and aluminum. These metals, when they burn, they produce heat up to above 2000 degrees centigrade. If you put normal foam or normal water on these hot metals, it causes explosion actually. But this product, with a very, very small concentration, 0.5%, that is half of 1%, 15 times less than the competitors, still can extinguish magnesium fire. And of course, crude oil will burn at 800 to 1000, and this is 2000 plus. So it is a multi-purpose, very unique product. See it for yourself. As a good safety supervisor, you should be interested also in a very important hazard that we have in the work site, which is a fire hazard, and in the method of its control. And one of these methods is using foam, and that is where NovaCool can help. Thank you very much. Bye for now. See you in next BB5.